This is Group 3. We will be discussing three major aspects of the manufacturing and processing of this bracket. We'll be talking about annealing, the piercing of the holes, and bending. First of all, annealing will be necessary because it will make all the processes that we'll need to go through throughout making this bracket easier, and it will get the sheet metal into the condition that we need to for the other things. Because there are so many holes, it's really important to take into consideration all of the hole diameters and the distance from the walls, that sort of thing. The diameters of the holes need to be at least 20% greater than the thickness of the plate where they're being punched. Also, the minimum wall thickness needs to be twice the thickness of the plate between holes, and also between a hole and the wall. For these non-round bends, that also needs to be taken into consideration for the bending. The punch that will be used for this will need to be beveled in order to decrease the force needed to punch the holes out of the bracket. And also for the bending, we need to take into account spring back, the shape of the bend, and the minimum bend radius.
Okay, so for the actual manufacturing process, we think that really any kind of sheet metal should work for manufacturing this, and what we plan to do is to duplicate this design but flip it 90 degrees over 180 degrees over here, so we'd essentially have a rectangle formation that would complete it with one single die that would punch out the same form on each and then cut it out to minimize excess material and to maximize the amount of things we can make with what we have. As far as sheet metal concerns and processing concerns, we looked at the guidelines for punching, lancing, and bending. Biggest concern with these methods is there's restrictions on how far and how close things can be. So as drawn as what we received from the drawn diagram, we're not sure if it would be able to be manufactured exactly to look like that, because this thickness over here was very short, and this thickness needs to be at least 3 times the thickness of the material. So we either use a really thin material and have it look like that, but that could compromise other parts of the design.
Okay, so this circle here, we'd have to lance it, as well as this rod on the plate. And then on the bending, we would have to bend past 90 degrees, so that way the spring back would be 90 degrees exactly. And then, so to calculate that, we'd use this equation here, but we don't really have the specifics of the material, so we can't exactly calculate that right now. And then we decided also that we would use air bending because we believe that that would be the best to get that 90-degree angle.
The annealing process that we chose is a process annealing. It's an intermediate annealing process that improves the ductility, bendability, and curl working without cracking or breaking. This procedure usually takes about 22 hours to complete at a temperature range just below 720 degrees Celsius. For cooling, we would cool in a furnace at room temperature, and we would be using a protective atmosphere, which would be a combination of nitrogen and hydrogen.